Hello friends, so today we're going to discuss a problem from the AtCoder Beginner Contest 142, problem name Get Everything. It's an E problem and the problem is based on DP with bit masking. So first we're going to go through the problem statement and the explanation, and then we're going to understand how to implement in code. So the question statement states that we have n locked treasure boxes numbered from 1 till n. So you're given some boxes, as you can assume, like n boxes. You can assume that they are lying in a row. Now a shopkeeper sells m keys, so he has m keys and n boxes. The ith key is sold for AINs, and it can unlock BI of the boxes. So as you can see that I have n boxes, I have m keys, or the shopkeeper sold m keys. The cost of ith key is AI, and the ith key can unlock these BI boxes which are given to you, which means that, as you can see in the example, so you have two boxes and the shopkeeper sells three keys. The first key costs 10 yens, and it can open only one box which has the ID number, as you can see, 1. Now he can also sell a keys which is the cost of 15 yens, and it can open the box with the ID number 2. And the third key has the cost equal to $30 or like 30 yens, and it can open two boxes, the ID with 1 and 2. So you have two boxes. So that's the whole case. You are given some keys and boxes and the cost of every key which can open the number of boxes. You are also given that. So now you have to find out the minimum cost required to unlock all the treasure boxes which is given to you. If it is impossible to unlock all the boxes, print out -1. Okay, so we're gonna understand this question with the example which is given to you. Let's assume that you have two boxes, as you can see, and they have three keys. The first key, which is of 10 yens, can open only one box, which is like the ID 1. Okay, I have another key which is of 15 yen, which can open the ID 2 box, and I have another box with the 30 yen price, which can open the box 1 and 2. Okay, I can either bought this only this key and open both of these boxes at the cost of 30, or I can individually bought both of these keys and open 1 and 2, and the price is equal to 25. As you can see, addition of both of them, so the answer is 25. So now I hope you get the point how to understand this problem first. Now how we gonna implement this problem? See, first we are given, you're gonna see that n is pretty small. N is pretty small, which is n is equal to 12. Whenever you got very small constraints, then the answer can be whether either you have to use some brute force way, or you have to use some DP, in most of the cases, not every problem, but in most of the problems. Okay, so I have to use some DP here. So now how you can implement DP and how you can use this constraint as an advantage for yourself? First, see that I have to assume that, because you can assume that I have a row of logs of 12 logs. Maximum they can be 12 logs. So you can assume to be a string, or you can assume to be as a number in which you have 12 bits to represent every log. So what I mean by that is, let's assume you have 3 logs. Okay, now for every 3 logs, you can assume that you have some number which is represented by bits, which is 1 0 1 1. Now because you are given that I can open the log 1 and open the log 2 with the cost of 30, so I can make a bit mask. Bit mask means that I can make a number in which I can mark the first log position, which is 1, the second log position, which is 2, and 0 0, and I will tell that, okay, this number which will represent that I can open the log 1 and 2 with the cost of 30. Then I can make another bit mask. Bit mask just means that I am representing the information I have using the bits. Okay, now I have one more case in which I can open the first log, so I can represent my first log like this, in which my first log is represented 1, other are 0, which means I can open the first log, and the cost for this is, let's assume that 10, and then I can represent my second log, which is like this, 1 0 0 0, and I can represent that as 50. Now I have some information, which means that I can store these bit masks in some vector or something like that, in which I can store that what is this value, this is equal to 3 in integer format. So I can store 3 and map it to 30. I can store 1 and map it to like 10. I can store 2 and map it to 15. This is not actually numbers, but this numbers will help us to calculate what is the particular like treasure box I can open and what is the cost for it. So I have just reduced down this information using bit mask. Now the DP problem. How DP will tell us to find out this value. Now what you can observe that I have for every key I have two options, whether I can take this key or whether I cannot take this key. To find out the final answer to open all the boxes, I have either two options. I can either take this key or I cannot take this key. I can take this key, I cannot take this key. So whenever you have such constraints, whether you have given some large value in which you have 2 or 3 choices, I have to take out this value or I don't have to take out this value, then what you can easily do here is make a DP table. So the DP table has two, so now you have to find out, okay, what are the like input values for a DP table, how we can define the DP state. So now my next question is how you can iterate over the values. So let's assume that I have two values in which I will start from the 1. I have index and I have the mask. This is called the mask. This is the this is not the mask. This is the mask, which is like this is the mask, and this is the cost for that mask. This is the mask cost for that mask. So I have two two constraints or like two things which I can use to define a state. I can use the mask for sure because I have to use my mask, and I can use I. I will tell us that if I take I elements from the start, and if I take I elements from the start and I have find out that this is the mask I can use, if I take this I elements from the start, what is the minimum cost I can, or which is the minimum cost I have to give. So how you can find out? Let's assume that I have some numbers. Okay, just take that example only, in which I have these numbers in which 10, 1, like there's a cost for a cost of 10 if I take this key, cost of 15 if I take this key, if a cost of 30 if I could take this key. If I move from the left till right, if I take this key or if I don't take this key, if I take this key, my initial mask is 0. Initial mask means, let's assume that this is my treasure. This denotes whatever key I can open. In the start I haven't opened any key, so my mask is 0. And what is the cost I have, or like what is the ID, how many elements I have taken? 0. Now I have option, I can take this element, I can take this first key. If I take this first key, my total cost will become 10. Okay, now I have taken this key, so I will move to the next key, but I have to update my mask. Why I have to update my mask? Because I have taken the key. I have taken this key, so now I don't have to find out this value. I don't have to like check that, okay, whether some other key have this, whether some other key can open this treasure lock or not, because I have taken a key which can open the treasure lock. So I have to update my mask. How I can update my mask? I have to do an OR operation with the current mask and the given mask I have, because the given mask will store out the key positions. If the current mask I have, if I do an OR of the current mask with the given mask I have, the ith mask, if I do an OR operation, like let's assume the starting mask is 0 and the first mask is this, then this and this bit will become 1, and now my new mask is only 1, like this, and the total cost I have incurred till now is equal to 10. Or the second case can be, I do not take this key. If I do not take this key, the total cost till now is 0 because I haven't taken this key. My total mask till now is again 0 because I don't have taken any key, so my mask is still 0 only. And now from this I will again do my next iteration, in which, because as you can see, I have taken two states to define a state. I, which will tell us if I take elements from 0 till I, and if I have found it out that this is the mask for those I elements, what is the minimum cost I can incur. Then this is the 10. Then I have two another options. I can take the second element or I cannot take the second element. If I take the second element, my total cost is 25 and my mask will become equal to 1 1, because I will again do an OR operation with the current mask, which is this, with the second mask, and this 1 will do an OR operation, it will get updated, and my next mask will become 25, total cost 25, and my mask will 1 1. If I don't take this element, my mask will remain this 1 0 0 0. My total cost is again 10. For this case, if I take this key, my mask will become like this 1 0 0 0. My total cost is 15. And if I don't take this, my total cost is equal, my total mask is again 0 0 0 0, and my cost is 0. Then, because I have reached a state in which my mask is completed, I have found out a specific way in which I can fill out the whole series. Like I have found out the whole, open all treasure boxes using this value. So I will store out that this is the minimum amount I can find out using this path. So I will store it out somewhere else. Else all the other paths we don't have found out any answer. So we'll keep on going out. And as you can see, for this is 0. For the next chance, if I take out the next key for this, it will again become 1 1. The mask will become 1 1 because the next key will update both of these values. And my total cost will become 30. But because my total cost is 30, but this is greater than the minimum cost I have stored for this point, so I will not update this. My total cost will 25 remain. My remainder is 25. And in the end, we will just output 25. So I hope you get down how we are using this bit mask and the how we define the state. So I will tell down to the code part now so you can like make it more clear. So code is also very simple. So you first define a DP table. DP table has two values, the ID, because the ID, which means what are the number of keys I have. The number of keys can get up to 1000 only. So I've just taken 1005, and this is the number of possible ways to, like, because I have 12 treasure logs like boxes at max, so the number of possible numbers I can form with this treasure box, like the mask I can form, is 1 like left shift 12 times. Then I can make an array vector A, which will store out the mask and the cost for that mask, because I have to first convert those those keys values into mask and the cost pairs, like cost pairs and the mask pairs. So I have to make this first. So what I will do, I will iterate over for every key position. What will I do? I will find out, or I will make a mask for that. I'm just making out a mask for that, but because the indexing of this is from 1, the indexing of this is 1, but I will just subtract out 1 from it so that my indexing is from 0. I will construct out a mask, and after constructing out a mask, I will push back the mask and the cost for that mask. Then I will start down my DP. I'm just doing it with memorization DP recursively, calculating it using this OK function. And then if in the end my answer is equal to this, which means that I haven't found out any answer, I have do my DP such that it is a very large number, then the answer is -1, which means that I haven't found out any answer. Else, if my answer is less than this, then okay, I have found out some answer. So now how this OK function is calculating my values, I will send out DP and the mask value. If the mask value is equal to, because I will return out or store out my answer only when my DP value is fully computed. How we can check my DP values for the mask is fully computed? This value can be calculated because this is the maximum value I can get when all the bits are filled. This -1, which means that all my bits are filled. So I will check that, okay, if my mask value becomes equal to this, then I will just return out 0, which means that I have, through this path from starting till this point, I have added down the values which I will take. And in the end, if I found out this path equal to the mask value, I will just return out 0, which means that okay, this path is verified. If I don't found out any path and my ID will become greater than m, m means the total number of keys I have, which means that okay, even after exhausting all the keys, I cannot find out any path, then I will return out a very large number. Okay, this means that if I have found out, or if I have stored out this answer earlier, I have to use a memorization technique. So I will check, I have initialized my DP with -1. If my DP value is not -1, I have used that. If this is not -1, then I will return out the DP value so that I will not recompute the task again. Else if I have not I have not computed this task, then how we can find out the value for this particular state? The particular state is I can either take this value or not take this value. If I will take this value, I will add the cost for this key which I am taking. So cost is stored in this second value and the first value is stored the mask. So because I have taken the cost for this particular key, I will recursively call this function again. I will increment my ID value because I have taken the particular key, and I will also update my mask. So how we can update my mask? I am taking an OR, which I have told you. I will take the OR of the current mask and the ith, because I have taken the ith key, so I will do an OR of the ith key with the current mask, and I will recursively call this function again. Or else, if I am not taking this key, I will not add this value to my my total value, but I will recursively call this function again, increment my ID, and the mask will remain unchanged because I have not added any key value. I hope you get my point, and I will return out the minimum of both of these cases, and that's the answer. I hope you get down the points and the question, the code itself. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.